Hello students, let us continue our discussion on continuous random variables in this part of our video lecture. In this class, we are going to discuss about continuous distribution function. Okay, we have already seen discrete distribution function in the video lecture of discrete random variables, if you can remember. Okay, if not, just refer to that lecture again, to this part in particular of discrete random variable. Okay, that means discrete distribution function. So what is continuous distribution function, which is analogous to discrete distribution function there? If x is a continuous random variable with probability density function small f of x, then the function fx of x is equals to probability of random variable x bounded by some small x, and it is given by minus infinity to x ft dt, where x is ranging from minus infinity to infinity. So it is how continuous random variable is defined. It is nothing but the cumulative distribution function. Okay, the cumulative distribution function. So it will get accumulated as you are going further and further in terms of x. So minus infinity to x, what will be upper limit for this integration? It will be x, that where the probability is restricted. Okay, and the interval will be minus infinity to x. Minus infinity here refers to the lowest part of that interval which we are talking about. Okay, so fx of x is equals to probability of x less than or equal to small x is equals to minus infinity to x ft dt is called as distribution function, or sometimes the cumulative distribution function CDF of the continuous random variable x. There are some remarks which needs to be studied. First is, in terms of discrete random variables also this remark, continuous may be wahi hai. So it will be 0 is less than or equal to f of x. That means continuous distribution function is less than or equal to 1. That means continuous distribution function or cumulative distribution function is always ranging from 0 to 1. Right? So second is fx is always a non-decreasing function. It is ever increasing. We have already seen this in terms of discrete sense, but how here it is playing part? Why? Because f dash of x is equals to d by dx of f of x, and we know that d by dx of distribution function is our density function. So it is f of x, and our density function, probability density function, is always greater than or equal to 0. First and foremost property of PDF is it should be greater than or equal to 0, and whenever first derivative is greater than or equal to 0, we know the principles of maxima and minima. So it is not maxima minima, decreasing and increasing function. Because the first derivative is always greater than or equal to 0, it is always a non-decreasing function. It is ever increasing function. Third is f at minus infinity, that means continuous distribution function or cumulative distribution function at the lower end point of the interval is always 0. How? Because f at minus infinity will be equals to limit as x tends to minus infinity fx, limit x tends to minus infinity to x fx dx, just now defined above. So whenever you are putting limit as x tends to minus infinity, that upper limit in the integration of which is x, now it will get to minus infinity, and hence minus infinity to infinity, same end point, so it will be 0. What about f at plus infinity? Again I am repeating, whenever I am saying minus infinity and infinity, I am talking about lower end point and upper end point of the given interval. So f at upper end point is limit as x tends to infinity fx, that means limit as x tends to infinity minus infinity to x fx dx, that means limit x tends to infinity minus infinity to infinity fx dx, where fx is PDF, and minus infinity to infinity fx dx is always 1, because sum of all the sum of all probabilities is always 1. I cannot say sum here because we are talking in continuous sense, so I should say integration. So integration of all probabilities is 1. Fourth note is, it may be noted that probability of a less than or equal to x is less than or equal to b, both included, that means closed interval. It is integration a to b fx dx. I am splitting it, integration minus infinity to b fx dx minus integration minus infinity to a fx dx. Can I do that? Can I do that? Just think about it. Can I do that? And let me know whether I can do it or not. Okay, I am not going to explain each and everything to you. You have to practice, you have to study. Okay, you have to show some rigor. So it is probability of x less than or equal to b minus probability of x less than or equal to a, and you know probability of x less than or equal to b is fb, capital FB minus capital FA. Similarly, probability of like whenever we are skipping the strict inequality less than or equal to sign and keeping strict inequalities at either or both here points here, we are going to get the same result, integration a to b ft dt or fx dx. T is dummy, don't worry about that t. Okay, so explanation of this fourth node you have to obtain whether I can write in this fashion or not. Okay, minus infinity to b fx, can I write integration a to b fx dx as the splitting of these two integral? You just let me know in the next class, okay, or write me in the mail, I will explain it there. Fifth point is to be noted is fx, that means the cumulative distribution function for a continuous random variable. Fx is continuous function of x on right. Whenever you are going on right, that means whenever you are increasing in terms of interval, whenever you are increasing the values of x, your function will get continuous. Your function is continuous in fact. Okay, fx is continuous function of x on right. We are going to see the diagram in the next slide. Let us see. Sixth is often we obtain a PDF, that is probability density function, from a distribution function capital F of x. Observe the notation. Capital F is distribution function, small f is density function. Do not get confused with small f and capital F. They have different significances, different definitions, and altogether different meaning. Okay, so be careful. We often obtain a PDF from a distribution function f of x by differentiating f of x, provided the derivatives exist. What they are saying that whenever you are differentiating the distribution function, you are going to get the density function. Beautiful result, provided the derivatives exist, obviously. For example, consider fx of x is equals to 0 for negative values of x, it is x for x between 0 to 1, and it is 1 for x greater than 1. Okay, let us plot this graph now. So you can see here, we can plot it like that. 0 to 1 we have x, and up to 0, let me check. Yeah, up to 0 it is 0, so x-axis only, no need to draw even. And from what I should say, from 1 to infinity or from 1 onwards, yeah, 1 to infinity I should say, it is a constant function on y is equals to 1 or f of x is equals to 1. The graph f of x is given in bold lines. Obviously we see that capital F of x is continuous from right and f of x is not continuous at x is equals to 0 and x is equals to 1. Yes, we can clearly see that f of x is not continuous at 0 and 1. Why? Because the limit is not matching from both endpoints. So that is not a continuous function, and discontinuity arise at x is equals to 0 and x is equals to 1. It is not continuous at those 2 points x is equals to 0 and 1. So there is no question of differentiability. So they are not also derivable at x is equals to 0 and x is equals to 1. Differentiating f of x with respect to x, what we get? You just differentiate it. What is differentiation of x? It is 1. What is differentiation of 1? It is 0. So we are going to define the function like this: dy dx of f of x is equals to 1 for 0 less than x less than 1. You can observe this. At 0, at less than 0 also we have 0 because derivative of 0 is 0, and at greater than 1 we are again getting 0. So 0 and 1 are both included in this strict inequality. It is 1. Okay, and 0 otherwise we have 0 as well as 1 when we are differentiating that function. Okay, you just check it, and if you are facing any difficulty, just let me know. Note, I also given the explanation. Note the strict inequality in 0 less than x less than 1, since capital Fx is not derivable at x is equals to 0 and 1. Yeah, important. Now let us define, I am defining a function f of x. Small f of x is equals to 1 for 0 less than x less than 1 is equal to 0 otherwise, exactly same as that of this one, which we have obtained using by differentiating the cumulative distribution function capital F with respect to x. I am going to say, just I am going to change the name, I am going to say it as, it is now f of x. Okay, we are getting the same thing as for probability density function. Then f of x, the fx is the probability density function for x. So what I have proved here, I have proved that this sixth point, The sixth point I have proved. What I have proved? The differentiation, the derivative of f of x, which is the continuous distribution function, is nothing but the probability density function. This is a very important result and it is going to be useful as far as solving examples is concerned. Right? Example 1. First example itself I have given homework because it is very straightforward. Okay, just practice it. Verify the following is a distribution function. Fx is equal to some function is defined. They have split the function into 3, x less than minus a less than x less than a, less than equal to x less than equal to a, and x greater than a. Hint is verify all the properties of distribution function as discussed above. We have seen some properties of distribution function here. Okay, verify all those for this function which is given, this one. Okay, also verify that the sixth property is also important. Also verify that d by dx of f of x is coming out to be PDF, which is probability density function. Right? You have to solve this problem by your own. If you are facing any problem, just let me know. Just mail me. I will help. Next example. Suppose the life in hours of a certain kind of radio. Yes, we have applications of probability and statistics in many fields of engineering as well as sciences. Okay, so we just cannot simply ignore probability and statistics here. Suppose, as this question suggests that we have many applications. Suppose the life in hours of a certain kind of radio tube has a probability density function fx is equals to 100 by x square when x greater than or equal to 0. It is equal to 0 when x less than 0. Find the distribution function. They have given us PDF and they are expecting us the capital F, that is distribution function of the distribution. What is the probability that none of three such tubes is a given radio in a given radio set will have to be replaced during the first 150 hours of operation? Reliability test. Okay, I have already mentioned this word reliability test in the beginning itself when I was telling the significance of studying this course or probability and statistics in particular. Next question is, what is the probability that all three of the original tubes will have been replaced during the first 150 hours? Let us see how to approach this problem. Probability that a tube will last for first 150 hours is given by, it will last for first 150 hours. So less than or equal to sign should be used. Okay, so probability that random variable x is less than or equal to 150. That means up to 150 it will not break. Okay, up to 150 it will last. So it will be probability of 0 less than x less than 100 plus probability of 100 less than or equal to x less than or equal to 150. I can always split that interval into two things because the function is defined like that for less than 100 and above 100, and they are just talking about above 100 means they are not going very far, just they are going up to 150. So 0 to 100 and 100 to 150 we are supposed to talk, but 0 to 100 the function is 0, so no question of integration. So first integration is 0. Simply they have written second integration between 100 to 150. So integration 100 to 150 fx dx, that means integration 100 to 150 100 upon x square. When you integrate this, you are going to get 1 by 3 as the answer. Okay, hence the probability that none of the three tubes will have to be replaced during the first 150 hours is 1 by 3 cube. Okay, it will be 1 by 3 cube because we have get the answer as 1 by 3 and we are supposed to take cube of that. So it will be 1 by 3 cube. So it is 1 by 3 ka whole cube. So 1 by 27. The probability that tube will not last for 150 hours, not means 1 minus the event. Probability of happening plus probability of not happening the event, their sum is always 1. So it is 1 minus 1 by 3 whole it is coming out to be 2 by 3. So probability of happening is 1 by 3, probability of not happening is 1 minus 1 by 3, it is 2 by 3. What was the next question? The probability that all the three original tubes will have to be replaced during the first 150 hours is 2 by 3 because probability of not happening that event, that means that itself means that all the three original tubes will have to be replaced. So 2 by 3 whole cube. Okay, so it will be 2 by 3 whole cube, which is nothing but 8 by 27. The probability that all three of the original tubes will have to be replaced during 150 hours is 8 by 27. Okay, fine. Next question is, a petrol pump is supplied with petrol once a day. if its daily volume x of a sales in thousands of liter is distributed by f of x is equals to 5 into 1 minus x whole to the power 4, 0 less than or equal to x less than or equal to 1. This is again reliability test problem, or I should say finding the limits problem, that up to what extent our model is useful. Okay, so there is one petrol pump. Okay, if its daily volume in 1000 of liter is distributed by f of x is equals to 5 into 1 minus x whole to the power 4 between 0 to 1, what must be the capacity of tank in order that the probability its supply will exhausted in a given day shall be 0.01. We have to tell that what should be capacity of its tank in order that the probability that whatever we are supplying to that petrol pump is getting exhausted, the probability of happening this event is 0.01. It is very beautiful question and it is very real life question, I should say. Okay, let the capacity of tank solution, let the capacity of tank in 1000 of liters be such that probability, I am introducing one a here, probability of x, which is random variable, is greater than or equal to a is equals to 0.01. Why greater than or equal to a? Because read the last line of the question. What must be the capacity of its tank in order that the probability that its supply will get exhausted, that means it should get emptied entirely. That means we are supposed to get a number a such that probability of random variable greater than or equal to, okay, greater than or equal to a, that number, particular number, it should be 0.01 because that exhausted word is there. Okay, there should be no leftovers. The probability, what is the probability that the supply will get exhausted for a given day, totally exhausted. So I should not put less than sign, I want greater than or equal to sign there because of that word exhausted. So it will be probability of x greater than or equal to a. Whenever greater than or equal to a is there, lower limit will be a and upper limit will be whatever may be the upper limit of your interval. Here it is 1. So integration a to 1 fx dx is equals to 0.01. Integration a to 1 fx is 5 into 1 minus x whole to the power 4 dx, which is 0.01. When you solve this, you will get 1 minus a whole to the power 5 is equals to 1 by 100. So you will get a is equals to, you just solve that integration. Nothing special is there. A is equals to 0.6019. Okay, that a value is obtained now. But do you want a value? Do you want a value? No. What was a? Let the capacity of tank in 1000 of liter be a. Okay. So in 1000 of liter, we have to revert back in terms of original units in thousands of liter a. So it will be a into 1000. Final answer will be, as the capacity of tank will be 0.6019 into 1000, which is 601.9 liters. So the capacity of that tank which we are talking about is, it should be 601.9 liters in order that the supply will get exhausted in a given day. The probability is 0.01. So answer is 601.9 liters. This is how we approach the examples of continuous distribution function. Okay, if you have any doubt in this, the two parts of this lecture of continuous random variables, just let me know through mail or through Google Classroom. I am always ready to help. Okay, so I will put some assignment question based on this now. I will give you some material on moment generating function, etc., and then I will put some assignment related question here on Google Classroom, and you have to solve that assignment. All right, all the best.